Hello, my name is JD Burnette. I've been a Master Gardener for about 5 years now. I've worked professionally, having to make some compost for a few different projects. I've also been passionately curious about this for some time. And I'm very happy that Marcia entrusted me to take on this, because I know it's been one of her big projects, or big presentations for several years. I hope to do justice here. So our title, From Waste to Wonder, Mastering Hot and Cold Composting for Greener Yards. So we're going to talk about why we want to compost, who's qualified to compost, when to start composting. We're going to talk about some science before we talk about which system and maybe how to do these different pieces. So why compost? Can't you just buy it? Well, you could, but you already did. When you bought the food and you had little leftover scraps, all those micronutrients, you could compost them, put them into your garden, and now you don't have to buy that. Seems like a lot of work. Well, yeah, I guess. It could be, depending on what system you use. But there's also a lot of work that goes into all the trash that you throw out, that someone has to pick up, that has to go to a landfill, that has to be processed. And it's really a bit of wasted energy, so it's best to avoid that if we can. Won't it stink? Yeah, it could. This is the point where you need to rely on your nose to let you know if you're doing it correctly. If it stinks, and we'll get into reasons why in our little science corner, it's just a symbol that you need to be doing this. You need to be turning it, putting air in the system. What about critters? This is one of the number one questions I get with composting. You can exclude them or include them. I'm gonna show you how to include them a little bit, just to say that there are possibilities, but I'm not really here to answer questions on that particular part. It's just to say, hey, you don't always have to exclude animals from your composting systems. But if you do want to exclude them, you pretty much need a barrier or some way to keep them out. And I know that that's a major concern for people. So I just want to, my overall goal is to let you know there are multiple ways to approach this problem. This is a really fancy chart by a couple of people. They made a pretty bold assumption or statement that essentially, if everybody composting, we can solve all these problems, from our physiological needs to our safety and security needs, social needs, esteem needs, self-actualization. It's a pretty grandiose idea, but they were thinking like economists and really put stock to flow ratios, process drivers, really thought about it from a business perspective. We depend on our soil to live, and composting helps that. I think that's the take from there. So a big compost pile. This guy looks pretty happy. This compost pile is generating heat so that he can take a 15 to 20 minute shower off grid. Just to say that your compost is producing heat. Maybe you've got a greenhouse. If you're composting inside your greenhouse, you might be able to heat up your greenhouse a little bit more. It took me a minute to figure out what was going on in this bottom right corner. He's got those wood chips there to collect this gray water. He then puts those wood chips into his compost pile so that he's, again, not losing any nutrients. Again, I'm not really here to talk about this situation, but I thought it was really neat. In Hawaii, they've actually started a composting system with pigs, and they're using microbes to cut down on the smell, to allow the processing to happen. Just kind of a neat system. This is another really neat system. This is Carl Hammer of Vermont Compost. I can't remember the amount of chickens, but something like 5,000 chickens help turn his compost. Yeah. So he's getting eggs and compost out of his system. It's some of the most expensive compost that you can buy in the United States. There are some places here in Tennessee that have bought this compost. I think if you're making your compost, you can do as good of a job for the price. But it's neat to see this system. The chickens are in there, they're going to eat a bunch of the weed seeds and pests, and this is bordering on both a hot and a cold system. This is the most important reason that I can tell you that why I think maybe you should be composted. This, I know you can't see it, but a lot of these studies are from 2015, 2008, and they're making the claim that about 50% of your household trash can be composted. So going back to that work equation, if you took out your trash half as often, does that allow you to have more time to compost? Maybe. Are you able to keep these nutrients on site? A little bit more. Yeah. So who's qualified to compost?
Everybody.
That's it. That's it. Did you eat breakfast today? You're already starting a composting process. So. Yeah, so everybody's qualified. You could even make the argument that the earth is one big composting system. So I use the example of worms here. 1,000 worms will eat about a pound of food a day, or a pound of scraps. Do you have the space? Well, you could have a little worm bin under your kitchen counter. Maybe if you do have a yard, you can do that. We can talk about scale as we go on into the system. There are also some options to donate your waste. If you just, at the end of this product, you're like, nope, I'm not doing it, but I care about this. There are some options here in Knox County, the city, to compost. This is one of the biggest limiting factors. Can you do the work? We're going to talk about systems that require more labor and less labor. I keep touching back on vermicomposting because these guys are doing the work for you. It's a smaller scale, easier to handle. You're not out there having to turn metric tons of material to create compost. And I'll have to fix this. My first time seeing it up here. So this let someone else, this is the options in the city and the county. Like I was saying, everybody's qualified. You live on Earth, you've got a microbiome, you're all already farmers. You're bacteria farmers. I included this quote because I think it's important. We struggle to sometimes define things, and soil health is like human health. It's hard to define. But you sure know when you don't have it. So this composting, it's going to create a beneficial feedback loop that you're both creating better soil and helping yourself heal and hopefully become a healthier person. So when to start? Today, yesterday, tomorrow, now. Are you going to create compostable waste today? Probably. We can be happy now and make compost, or we can be unhappy and make compost later. I don't know who said it, but it gave me that trouble too. And so here we're going to get into some of the science bits and really start getting into some details. So who cares where all this carbon goes? Maybe that's your stance. It's not mine, but you're free to have your opinions. And the point is that your soil would love to have that carbon. Through tillage and different processes, we've broken up a lot of microorganisms and different things in the soil where that carbon is trapped. Up to a point, we can see where this always has beneficial returns in your garden. More carbon in your soil, healthier vegetables, et cetera, et cetera. Compost is an engine. I really like this metaphor because it helps, I think, take away some of the opinions that people might bring to whenever we start talking about a few of these things, and really lets us step back. What's going on here? What's the science? And I was also told that NPK was all that I needed for my plants to grow. Well, it's not quite right. Boron may bore you, but it plays a role in this entire soil ecosystem. So in 1 square meter, I'm not even going to try and whatever that number is. There's a lot of zeros there. There's a lot of bacteria in your soil. And it goes up. The higher, the larger the organism, the less of them there are per square meter of soil. So these are some of the things that are taken care of here. They need more than NPK. So the composting engine metaphor that I was using earlier, I really like it because carbon, it's going to act a lot like the cylinder to contain the explosion that's happening in your composting system. It's got 4 sites to bind to. It's the building structure. Nitrogen, it's kind of like the spark plug. You need it for DNA, for protein synthesis, for life. Some people make the argument that hydrogen, they consider nitrogen as the gasoline and hydrogen as the spark plug, but getting a little bit nuanced in my metaphor. The reason why I would consider water to be the gasoline is because the hydrogen ions, they allow pH change, and they also allow for chemical reactions to happen. It's very hard for a chemical reaction to happen outside of an aqueous solution. So this is why your compost needs to have some moisture to it. We talked earlier about how if your nose can smell it, that your composting might not be quite right. This is because your compost needs oxygen. With the heat that we showed from that shower, there's combustion happening. There's chemical reactions that are releasing heat. So they need this oxygen in order to create this cycle and let that process get started. You don't get far in your car without a good intake. Back to the micronutrient bit. How many of you are familiar with photosynthesis? Okay. What is the first element that is required for photosynthesis to happen? Sunlight. Okay, I'll take sunlight. It's not quite the chemical that I was looking for, but it's the process. So as sunlight's coming down, it hits the leaf surface and there's an electron that gets popped off. The first thing to lose its electron is boron. Without boron, you can't photosynthesize. The plant can't make any energy without it. So once that electron gets popped off, the cell division starts happening, and then these different elements. There's no NPK in this chart yet. So your micronutrients are very important. Another reason why your composting is very, very, very important. I really like this quote. Obviously, there are some limits to it, but if it's lived before, it can live again in the medium of compost. I share this because you're often told like what you can and can't compost. There are very much truths to that, and very much to set you up for success. There are things that you should avoid. In the grandest terms, it's all compost. So which system do you want to use? I apologize for my internet, but my screen versus this screen is show up. So which system? We've talked about a couple different pieces. Vermicomposting is probably one of the main pieces, and in your handout on the top resource there's a link to all the details that you need. That's on the back side of the handout. It has everything you need as far as the specifications, how to build it. You know, it's the very technical details. My goal today is not to give you the technical details, but help you think about this process and decide what fits your context. Because maybe you don't care about worm composting because you can't stand the side of them. But I would argue that they're the least amount of work. They are able to be done on the smallest scale. They're free labor, but they are easy to overfeed. Now I've mentioned a couple of different options. Most people are familiar with earthworms. Well, mealworms, interestingly enough, I've got a buddy who's using them to break down all of the styrofoam packaging that he gets. Yeah, I mean, I maybe don't want to put that, I don't know, I want to see the research on what that after product is, but it's at least being broken down in a way that, 10 years ago, nobody thought was even possible. So whatever's going on there, it's interesting at the very least. Black soldier flies, I share them because if you have a worm bin outside in the summertime, you're probably going to see these guys show up. They're actually beneficial. They actually outcompete fruit flies and other disease-causing flies. In their adult stage, they don't have a mouthpiece, so they can't land on food and transmit disease in the same way a fruit fly or something else can. So these are a relatively safe option if you want to have a system solely devoted to them. They also can break down many more. They can break down citrus, bone, a lot of different things that earthworms and mealworms can. They also, there's some an enzyme called chitinase that their waste seems to be really high in, and that chitinase helps break down chitin, which is normal exoskeleton bug. So there may be some other benefits to using these different types of compost that you're able to create. Probably the biggest benefit with the earthworms is that they're going to create something called glomulus glomulin, and that's what's responsible for keeping your soil structure and allowing it to compact. We don't really have a lack of that too much here in our clay soils, but they're still beneficial. Let's see. Yeah, this has gotten all out of whack here. I'm going to have to think about that. All right. So the next type of system, we've got a thermophilic. This is your hot composting. So you might be familiar with a 3-day system or the Berkeley method. I've got a few more pictures, but this is what you're probably familiar with when you think about turning compost. This is kind of your mid-level scale. It's probably where most of you all are at. Like I said, it's easy to overfeed the worms, but we'll get into the details of the thermophilic situation. It probably is the most work. It's the average scale. It is also the fastest. And while technically you don't have to create a 3-bay system with like built infrastructure, you could do this with a pile on the ground. I mean, you don't have to build something to get started on this. And then we're going to touch on the Johnson-Su method. I think they are doing some of this up at UT Gardens. I believe I heard they were building some of these in training. It's probably the most studied composting system because it's a static pile. But it's meeting a lot of these thermophilic situations, and we'll get into the details of that in a moment. The other reason why this is one of the most studied is because they can control the most amount of variables. It makes it just easier to study in a scientific setting. If the air temperature, if the pressure changes, if you waited 15 minutes to turn your compost compared to yesterday, you start getting into variables that can be scientifically disputed. So that's why all this research is really right now being pointed towards Johnson. It's also making a phenomenal composting product. This is a really fancy scientific chart, right? It's a judgment-free zone. Your mileage may vary, and that's okay. You know, the point is not for you to come out of this class or whatever to create the best compost or for the system to be the best. But, you know, there are benefits to different systems. So this Johnson-Su system, it's really high in the fungi whenever we're looking at it under a microscope. So if your soil is missing a lot of fungi, it may be a good inoculum, soil inoculum to use. It's also pretty high in bacteria, not as high in nematodes, and decent in protozoa. So different systems are going to have different benefits to your soil. So a nematode, that's a fancy name for a worm. There are different sizes of worms. Protozoa are just another type of microbiology. It's not, I mean, it's important, don't get me wrong, but the fungi and the bacteria are really the two things that if you just have a base level understanding of, that's really what we're cultivating and growing in our composting pile. Whenever I read this quote, at first, it just, I don't know, it allowed me to humble myself a little bit. And the more I thought about it, it's like, wait a minute, this is what's going on with compost. Like, compost is kind of nothing, but if we put some time, energy, some love into it, life flows. So, all right, we're going to get into the how-to section. This is, I know why we're all here. I've probably spent way too long talking about the other bits. Maybe we're on time. But 1, 2. So, you've listened to this, you don't care. I hope not. So there are some programs going on in the city and in the county. They'll take your compost and put it to good use. You know that person who brings you all those squash, all those tomatoes? They would really appreciate your scraps, if you sorted them. I'm not going to talk too much about the mealworm composting system. I don't know enough about it. The worms and the black soldier flies we can touch on a little bit more. Hot composting, we'll touch on the 3-base system or something called the Berkeley method, which is more the theoretical limits or how quickly this could happen. I've never been able to make compost in 18 days, but that's what the science says is possible. And then the no-turn system, Johnson Sewer, Animal Integrated, I just mentioned those at the beginning. I will give you some information, in fact, on the back, all of the details for how to build the Johnson Sewer bioreactor, the PDF on it, I forget if it was him or his wife that they got their PhD based on this research, but it's all right if you want to look it up. So, if you want to drop your waste off, the city has a program. They've just expanded it a little bit, and if your community garden is needing a composting system, there's actually a grant for that. That's in the next slide. I put the link up at the top. If you go to the city's website, you can navigate to this. I'm sure if you search composting, there are a couple locations. Enhance, to show you the addresses down there. But there are multiple pickup locations. So this link, and I wish I had something better to share with you. It will get you to a compost bin application form. So the city of Knoxville, they've got a USDA grant. There's also I can't remember all the projects that are involved in this, but they will help you install and build a composting bin on your site. I think they're looking for, they've got all the details on this link. I should have maybe made some notes about it. You've got between now and this time next year to apply for it. They basically just want you to report that you're using this thing, and they want to see some pictures that it's in use. So if you can't build a 3-bay composting system at your house, maybe your community garden, your church, some.
But they are for private residents too.
This is not.
Okay.
So is the compost that Knox County gets, is it made basically for Beardsley Farms?
I don't believe so. I'm not sure what their system is. So I know that this is the city that's doing this piece, and so that's where you can drop that part off. The county, this is like a grant so that people can start composting out.
Right.
As far as how the city operates, I know that they're using some green waste and different things, but I suspect that they probably have to buy some amount of compost commercially.
So basically this is a new system, so they haven't really gone gung-ho with people in Knoxville and Knox County?
Correct, yeah, I mean this started 1 year ago, and for the city.
I never even heard that they were doing that.
I know, right? It was very small scale. I think they only had three small sites. And really what their goal is to allow Beardsley and these other community farms, Battlefield Farms, they need compost. So, you know, if you don't want to compost and you want to take your scraps and help them get compost, that way they don't have to buy it.
I do know the Alliance got their 3-bay, and it's huge.
Yeah.
Shed that they have there at the Payne Avenue Church. And they got that through this grant for that community garden there that can compost and then reuse that compost back in their raised bed. So it's a wonderful cause. It's a wonderful cause.
Absolutely. And do you know they cover all the costs for it and build it?
Yes.
Yeah. So.
Yes.
Yeah, I mean, I think all you have to do is apply and connect your community garden and or church garden. There might be some more details on like who can apply, but I at least think it's important to share because we all need to be composting a little bit more. So this is my worm bin that I built. I was sitting at the house and I was like, you know, I'm just gonna go do this. So I went to Dollar General, bought these little, I think they were $1 a piece at the time, drilled some 1/8-inch holes in the bottom, stacked them, and afterwards I realized that I probably should have left one that didn't have holes in the bottom. So I had to put it on something. I like burlap sacks, a burlap sack to put on top. It made it a little bit cleaner for me. I know some people just use like newspaper and that sort of stuff, but I really liked that layer because it was easy to pull back, it was easy to separate, it kept moisture in there really well. I don't know, somewhere in my mind I think that the words were like, oh, this is a condominium, this is really nice. One little point to touch on with the worm bins, I think actually this might have been the second worm bin that I created. The first worm bin I created was out of a big tote, you know. Well, the type of worms that I'm using don't go down very deep, so it's more about surface area than it is about depth. This is the 3-bay system. The way that a lot of people will use this, they'll fill this first bin, flip it into the second, continue to flip over. Each time the pile will reduce. I kind of like to turn it. There's also, it's not quite clear on here, but you can, the piece that I shared back here from the details, this 3-bay compost system, they actually build it so there's slats that come out of the front so that you can get in there and with a shovel and turn it a little bit easier. I would also recommend chicken wire as opposed to boards so that you get more airflow. This third bin is supposed to hold the compost for you, and as she was talking about, she mentioned that their system was huge. There's a minimum size that you have to have. It has to be at least 1 cubic yard. Otherwise, it's not going to have enough thermal mass to get up to heat and carry out the composting process. I brought these tools. You do not want to turn your compost with this. This is not what you want to turn your compost with. It will take forever. I mean, if that's what you have, that's what you have. But this will both get more and allow you to have more leverage as you set it over the edge of your bin. You know, it's much easier to work. So this is a manure twine or a manure fork. I think it's also a 9-tine or 8-tine fork. And I prefer the longer handle there. You'll want some sort of rake to kind of clean things up around the edges. Some people like a leaf rake to get it really, really clean. I find that I usually have somewhat chunkier materials that I need to get around. So I prefer the gravel rake over the rake. This is an example of that system. So the first bay over there would get filled up. It would break down in 30 to 60 days. And we put it into this piece, and in the final bed here we have finished compost. So this was 90 to 120 days for this system to work. I actually, if you get in there and turn it, it'll be faster, and that's part of this Berkeley method. So the theoretical limits are that you could, with every variable being controlled for, you could create compost in 18 days with a pile just in the middle of the floor outside. And so you want to mix this pile, making sure that you get your carbon and nitrogen ratios correct. So in the pamphlet, I mentioned the carbon and nitrogen ratio. You don't need to go home and bust out your calculator, and it's just to have an idea that things like sawdust are going to be very high in carbon. And this is the part of, I would argue that composting is as much of an art as it is a science. There's rigorous science involved. But as you kind of get to feel your way around with the different inputs, this is where the art comes in. So you don't have to know exactly what the carbon to nitrogen ratio is. For example, if you get leaves at a different time of the year, in the fall they're going to be higher in carbon. If you get them in green leaves and in springtime they're going to be higher in nitrogen. So the more green it is, the more nitrogen, the more brown it is, the more carbon. Ideally, we want to have about a 30-to-1 ratio in our compost when we get started. If you're really getting down into the nitty-gritty details, I think it's like 23-to-1 is where they're producing some of the best compost. And by the time you get to this finished compost, that carbon to nitrogen ratio is closer to 15 carbons for every 1 nitrogen. So I share that to not to make you freak out about the numbers and think that they're so important. Just that that's the chemistry that's going on behind here. You also notice with this, there's a timing to this. So there's 3 days where they don't turn this compost initially for the Berkeley method. It needs to sit long enough that, again, that all those chemical reactions can start kicking off. At that point, we want to turn it and check the water content. And 2 days from then, do not stick your hand in it, because if you've done this properly, it should be about 165 degrees, which can burn you. So this is where you should have a compost thermometer, and you want to be checking the internal temperature of that compost pile. This is really if you're on track at day 6, you might be able to make compost in 18 days. You notice in every section, check water, check water, check water. So regardless of your vermicomposting system, your 3-bay system, this Johnson-Su system, or the Berkeley method, you want to check for something called field capacity. So it's basically to say how much water can be held in the soil structure. So if you pick that up and you squeeze it and water just runs out, it's beyond field capacity. If you squeeze that and maybe you see like one little drop, it's at field capacity. So that's as wet as you ever want your composting to be. It's at field capacity. You never want it to be beyond field capacity. So this process, they just turn, check. They're putting the water, the oxygen, the carbon and the nitrogen are already there. So this engine is really starting to go somewhere. Personally, it's taken me about 30 to 45 days to be satisfied with the results of this compost. The Johnson-Su system. I tried to build one of these once, and I didn't have this. That's the key. So one, it's going to hold all these PVC pipes up for you, but it is also, they are strategically placed so that everywhere in this vertical pile, they're getting equal amounts of oxygen. That's the big piece that's happening. This is why you don't have to turn this system, why it's still creating a thermophilic type product. but it requires a lot of work up front and at the end. On the farm where we built it, we ended up using a bobcat to fill it because, it's tall, you're trying to, anyways. It may not be a system for everybody, but I don't know, maybe it is, because you don't have to turn it. You're able to build it, and 1 year later, you can basically take the wire ties down, and the pile's just there for you to dig from. You don't have to dig it out of that. All 3 of these links, except for maybe this presentation, are shared on the back of your handout. That presentation is a 45-minute talk of him just really telling you why the science is so good on this. I think it was like 1 teaspoon of their finished product was able to inoculate like 1,000 square feet with beneficial microbes. That's saying something for a compost product. There's the other piece that I want to mention here. He was using 1/3 manure, 1/3 greens, 1/3 browns in his system. So that's obviously a limiting factor, but there are places they start. You can get finished compost manure there, and that might be a way for you to substitute having to deal with fresh stuff. There's also Facebook groups and all kinds of people who are nerding out on I added worms to my system in the last 30 days, and it was this much better. I used bone meal as a thing. So anyways, there's people nerding out on all kinds of details and experimenting with this foundation. Shared several books here. If any of the things that I've said really interest you, Jeff Lowenfels, he can really help distill this complex science down into something that is not just big words. And I like all 4 of his series. This other gentleman, David Montgomery, this was actually part of how I got into soil and composting. I can't remember if it was Dirt or The Hidden Half of Nature that I read first. Dirt makes the argument that Uncle Sam needs you to compost too. Civilizations are, composting is as important for you as it is for your neighbor, as it is for the longevity of whatever civilization you're part of. That's the argument he makes there. This other piece, Hidden Half of Nature, him and his wife, they actually started out trying to learn how to compost. And during this process, they discovered how important the microbiome was. And so he talked to the people that approve his book writing. And he's like, hey, I've got to change my book. It's no longer just about composting. It's got to be about the microbiome because it's so interconnected. And I haven't read this one. So why compost? We want to create nutrient-rich humus because we're humans and we depend on this humus to survive. Who should compost? You, your family, your community, everyone. When? You already are. So what is composting? It's a science and an art. And how you can drop it off, you can build a system, you can maintain the system, you can use it and benefit from it. Does anybody have any questions?
Are you going to say anything about critters?
Yeah, so critters, it's the reason why I didn't really include anything because it's going to vary. What critter you're dealing with. That's a thing that you have to start with.
I don't have any problem, but I've heard people say I won't compost because it may attract rodents.
Yeah, so you are absolutely putting things out there to break down that are going to be a food source to something. Your compost pile is going to become a food source. So the way I like to keep critters out is an exclusion barrier. So depending again on the type of critter you're trying to keep out. So I've seen some people, they will just you know, like a dog kennel, they have their composting system built inside of like a metal cage dog kennel, so that they can get in and out. Obviously, you know, if it's the chain link style, it's, you know, a rodent can get through that. So you could put in a chicken wire or something like that on the inside, again, to keep them out. So an exclusion barrier is the answer to critters.
That you would say absolutely do not put it in your compost?
So typically you want to avoid things like citrus, things like fats, bone, so like animal byproducts. Those are typically things that you're going to want to avoid. And part of this piece is to keep the rodents out. It's not that that stuff won't break down, but it's going to attract rodents. It could become disease. It could encourage disease-causing microbes to live in your homes. We don't want that. So I would avoid those things until you feel like you're on top of your composting.
Why citrus?
Say it.
Why citrus? Because it's a plant material.
Yeah, so the citrus piece, it is a concentrate. It's more for the vermicomposting systems that they just don't want to eat the citrus. But even in your standard composting system, it just takes longer to break down. You know, the vitamin C and the different pieces that are in there kind of act like preservatives. So they'll just change the chemistry that's happening.
Recommend putting the compost pile in direct sunlight, more in the shade? Where should we position that?
So depending where you're at, time of year, it could factor how hot your pile gets. Now, I actually like to keep my compost pile covered because we get so much rain here that I don't want it to get soggy and wet because it's hard to, so out of the sun is probably going to be your best bet. And the UV also harms all those small little microbes too. So.
On a 3-day system, do you think that's important to do that?
Especially if you want to keep critters out. So if your system, if you have built-in drainage at the bottom, you don't have to. But if you're not, if it's getting soggy in there, it's not going to compost correctly. It's one of the common troubleshooting problems that people deal with. Yeah, so if there's too much moisture in it, you're going to want to turn it more often, which makes it harder for it to get up to.
The City of Maryville has free compost available to pick up Wednesdays from 8 a.m. to 1 p.m. At their wastewater treatment plant on Wheeler Road in Louisville, and it's available free of charge. It doesn't say you have to be a Maryville resident either. I don't know. I have
You had a slide when you were showing the 3-bin method,
Yes.
and they were saying bin number 2, bin number 1, take the top layer and put it in bin number 2. That feels backwards to me. Isn't it the bottom that's going to break down faster?
Well, depends on the oxygen situation.
Okay.
Because at the bottom it's going to have less oxygen, so it might not. But also, there's a piece about this that you're essentially inoculating the next day with your whole system. So like I don't know, as I understand, like for making sourdough, it's best to have like a starter that it's kind of the same deal.
What temperature should you be shooting for the fastest, most?
Great question. So 120 is the minimum. 170 is the maximum. Whenever I have been on it, 145 and 160 is where I was like getting the best, the quickest results. What's kind of interesting with this Johnson Sioux, the research that they're doing on that, temperature influences microbial populations, so you may get a better product at a lower temperature, but it's probably beyond what you really care about. They're all going to work in your garden.
I've read that if you have the temperature high enough, it'll kill a lot of weed seeds, but are there particular kinds of weeds you might want to avoid putting in there? revenue?
This is a good question. I am not familiar with any weed seeds off the top of my head that can survive, once you're getting up to full temperature. Does anybody know of a subnoxious weed that survives thermophilic composting? Like some things can still, like in this process, things will be germinating. And that's part of if you allow them to germinate and then it gets hot, they'll die off. I guess, there are things that it won't break down. So for example, like if you're using a horse manure that has a broadleaf herbicide in it, it's still going to be in the composting system. It's going to take a long time to break down. So that's the closest.
I think back to the weed seeds, I use a lot of the wire bins,
Yeah.
and the center is always warmer than the edges.
Yeah.
And so if the weed seeds are on the edge, it's not as hot, they won't get killed. So you really need to be turning it religiously so that they eventually end up in the middle where it's hot, but that's kind of hard to guarantee.
It's a great point.
So I tend to not put weeds with seeds into my compost.
Okay, so you just...
I may cut off the seed head and compost the rest of the plant, but I try not to put the weed seeds in.
Nice. Yeah, that's definitely a way to save yourself from that trouble at the end. Have you tried like anything that I know, so like dodder, for example, we had it.
Yeah, I've never had to deal with dodder.
Yeah, I didn't put it in the composting pile, but I'm curious if it...
Yeah, I don't think I'd risk it.
Me either, yeah.
I also don't put Bermuda grass in the compost pile.
Yeah, that I will say, it will creep into your compost pile because of the heat.
Hey, you talked about the minimum size, starting with a cubic yard, which is a yard 36 by 36 by 36.
Yeah.
Talk about how much you get out of that.
It's about a third of the volume at the end of it. So you get about a third of a yard after you build a cubic yard. If you have a higher carbon ratio, so say you're at like 40-to-1, you'll have more volume at the end of that process. So it can matter how much, what your carbon nitrogen ratios are, but you lose a lot of volume. There's a lot of open air in that.
Get a grinder to help speed along the process? Not necessarily that, it's just kind of just an extra expense.
Yeah, I would register it under extra expense. Like if you're running a commercial operation or you just have to, if you really want to get to the limits of this 18-day compost just for your own curiosity, okay, grind it up. But
Urban shears, kind of small things. Just chop it up with a shovel and sort of that too.
it doesn't have to be, super small.
No, but if you're composting in the fall and you've got a lawn and you've got leaves, you run over it with your watching lawnmower, collect them in the bag.
And that will also help with having less of a reduction in your pile because there's much airspace in those big full leaves.
When I started this, I also made a separate bin for just nothing but leaf to create leaf mold and stuff like that. And I guess it's sort of a similar process, except we really don't have much of any nitrogen. But everybody says leaf mold is so great as a soil amendment or whatnot. So is there any benefit to doing that separately from your regular compost?
So I would say yes, and the details would come down to the soil science that's happening, like what microbes are present that are being created there versus this other composting system. I couldn't tell you what those microbes are or what the specific benefits are, but just to say that the soil relies on a diversity of microbes. And so the more diverse microbes you have in your soil, the better the product is going to be.
Well, basically leaf mold ends up being compost without the nitrogen.
Yeah, so I think like oak leaves, I don't know, anywhere between 40-to-1 and 80-to-1. So that 40-to-1, like technically that'll compost by itself, and that's it's just a higher carbon compost. There is nitrogen there, it's just not a lot. And maybe the benefits are more about getting the carbon into your soil than actually having a nitrogen nutrient for the plant.
How much do worms eat? How much kitchen scraps do you need to feed a typical worm?
So usually that the 1,000 worms is about a pound of worms, and they eat about their body weight in a day. So
Oh, 1 pound.
right, yeah. So which is not that much if you watermelon rind, for example.
Oh,
You know,
okay.
like, so you do need a pretty substantial worm population in order to feed it a lot. Their population doubles 45 to 90 days depending on the species. So that's under optimal conditions. So you may be able to start with a small amount and get up to scale pretty quickly. I think I've answered everybody's questions. I don't see any more questions going up. So, yeah. Well, thank you all very much for joining us today. Appreciate it.